Hello, my name is Patel, and I will be doing my presentation on bridge design pattern. Intent. So the formal definition of bridge design pattern is that it decouples an abstraction from its implementation so that the two can vary independently. What this basically means is that both the abstraction and implementation classes can be modified without affecting each other. The pattern essentially creates a bridge between abstraction class and the implementation class. So, motivation. We can use a bridge design pattern when we need to avoid a permanent binding between an abstraction and its implementation. We can also use it when we need to share an implementation among many objects. Additionally, we can also use it to hide the implementation from an abstraction completely from its client. When to use it? We can use the bridge design pattern when we see that we want a parent abstract class to define a set of basic rules, and the concrete classes to add additional functionality. Additionally, we have an abstract class that has a reference to the objects and its abstract methods that will be defined in each of the concrete classes. So structure. In the structure, we have four main participants: the abstraction, implementer, refined abstraction, and the concrete implementer. So the abstraction, as you can see here, is the center of the bridge design pattern, which defines the abstract interface. It also maintains a reference to the implementer. The refined abstraction extends the abstract interface defined by the abstraction right here. The implementer basically defines the interface for the implementation classes, and the concrete implementer implements the implementer by providing concrete implementation. So the consequences of using bridge design pattern. For one, it increases complexity. Secondly, it negatively affects the performance due to the fact that the abstraction needs to pass messages along to the implementer, which slows down the entire system. So some of the known uses of design patterns can be seen in MFC, the process of storing and retrieving an object to and from a persistent mechanism, is called a serialization. MSC uses bridge design pattern to implement serialization. Another use is in Java, which uses bridge design pattern to separate components and component peers. Third unknown use is the ET++ window/window port design, which extends the bridge design pattern in that the window port also keeps a reference back to the window. The window port implementer classes uses this reference to notify the window about port specific events such as arrival of input events, window resizes, and etc. The next applicate also uses a bridge design pattern in the implementation and display of graphic images. So for my demo in bridge design pattern, I've created a scenario where we have two TVs, an LED and an OLED. Additionally, we have two remotes, which will both work on both the TVs, the LEDs and OLEDs. So what we'll implement here is using the bridge design pattern, we will take the abstraction of the TVs, so it will be TVs will be an abstract class, and use it to bridge to the implementation of the remotes. So here's the UML diagram for my scenario. We have the TV, which is the abstractor. The OLED and LED classes are the extension of TV, so they extend the abstraction interface. The TV abstract class also has a reference to the remote interface class. It is the implementer, and remote 1 and remote 2 are the concrete implementations. So taking a look at the abstract TV class, I have created a constructor which will take in remote 1 and remote 2 type objects, and has two abstract methods: increase volume and decrease volume. The refined abstraction class LED, which extends the abstract class TV, um, basically implements the two abstract methods, increase volume and decrease volume. The refined class OLED does the same thing with a different message. Next, we have the implementer class remote, which pretty much just implements or pretty much creates an abstract method volume. So remote 1 is the concrete implementation class, which implements the interface remote using its own message. Remote 1 using the method volume. And similarly, remote 2 implements its own message, remote 2, using the volume method as well. Lastly, I have the client class, which implements, which tests out the entire system. So as you can see, we have a LED TV type object LED TV, where we implement the remote 1 and remote 2 in the LED class, in the new LED class object, and run the increase volume and decrease volume methods. Similarly, we do the same thing for the OLED TV. And the output, as you can see, we have LED TV increases volume with remote 1 and 2, LED TV decreases volume with 1 and 2, OLED TV increases volume with remote 1 and 2, and OLED TV decreases volume with 1 and 2. So my demo essentially proves that we have separated the abstractions TV from the implementer remote. So we can change something to the TV classes or extend on it without it reliably affecting the remote class. And this is my client, or my program. These are my classes: TV, LED, OLED, remote, remote 1, remote 2, client. And here is my output. As you can see, it output the correct output. Thank you for watching my presentation.